Bom dia, bom dia, bom dia. Sejam todos muito bem-vindos. Mais uma webinar técnica. Nós temos esse compromisso da Color Mix desde fevereiro, a cada mês desse ano, trabalhar nesse momento de pandemia, de afastamento, com o máximo de compartilhamento de conteúdo. E hoje a gente vai ter um dia muito especial com a nossa parceira Ecart. Eu quero de cara agradecer aqui a todo o apoio da Cris e da equipe da Ecart. Hoje nós vamos ter a brilhante apresentação do Peter Wiesling, um super técnico, um especialista da BIC, desculpem, da Ecart da Alemanha, para que a gente possa conhecer mais sobre o ZincFLAKES. O ZincFLAKES, que é um produto super inovador e super adequado para os processos de proteção anticorrosiva de altíssima performance, né? Então, hoje vai ser um dia dedicado a esse tipo de assunto. Espero que vocês aproveitem. O Peter é um cientista, é um especialista da matéria. A Ecart é uma das maiores empresas do mundo nesse sentido. Então, tenho certeza que nós vamos ter um ótimo dia. Os protocolos habituais são aqueles que vocês já conhecem. Aqui embaixo, a gente tem aí na barrinha as questões sobre perguntas. Então, o nosso material vai estar sendo transmitido ao vivo pelo YouTube e também pelo canal do Zoom. As perguntas podem ser colecionadas aí no Questions and Answers e também podem ser feitas lá no YouTube, na área de perguntas, no chat do YouTube. Fiquem à vontade. No final da nossa apresentação, nós vamos ter a vinda aqui do Alexandre, nosso gerente comercial, que vai comandar o Perguntas e Respostas, um bate-papo com o Peter. Se você tiver interesse de conversar com ele, de interagir, levante a mãozinha e nós vamos abrir sua câmera e seu áudio para que você converse com ele, troque ideias e debata. Então, eu espero que a gente tenha aí um excelente dia com bastante aproveitamento, bastante novidade. Nós temos novamente que agradecer muito a presença de vocês, muito ao apoio da Ecart e do Peter, e espero que façamos aí um bom trabalho. Peter, welcome, muito obrigado, thank you for your attention. Come in.
Hello, everybody. Good morning to Brazil. Thank you, Abreu, for the kind introduction. I am very happy today to host this seminar, and special thanks from my side to the whole Color Mix team who did an excellent job in advance in preparing this event. To everybody attending now, also from my side, thank you for your time. I hope at the end of this more or less 1 hour event, you will return back to work with the impression it was worth it. And as Abreu mentioned, please feel free to ask any question through whatever channel you want to contact us. I start now. So please indicate to me, is the screen visible now?
It's visible, Peter. Go ahead.
Thank you. Thank you very much. So once again, I am excited always what is technically possible. I am talking to you from the southern part of Germany, nearby the city Munich, which you might know. And you see a picture of our plant, the Eckhart plant in Germany, and you see a blue window marked, and that is the window out of which I talk to you today. And I would have preferred to talk to you face to face. That is unfortunately not possible. So please enjoy today's presentation, the Q&A session later on, and then I hope to meet some of you, all of you, later on, maybe at the end of the year or next year, face to face to discuss further. Allow me to start with a few basic principles about corrosion before I come to our product offerings of ZincFLAKE products. Corrosion is an electrochemical process whereby, in the presence of water and oxygen, iron is oxidized to iron oxide, so-called rust. During this oxidation process, an electron transfer occurs, and this is very important to have three components: water, oxygen, and the electron transfer coming together in one place to allow rust occurring. Chemically, rust is iron oxide hydrate. And from this graph, which is relatively unimportant, but you can see that the rust is a very voluminous species, the most voluminous species out of all the iron oxide species. And because rust is so voluminous, it can penetrate between the steel substrate and the paint film, by that removing the paint film from the substrate. The steel in that corrosion process is oxidized, disappears away, the paint is removed, and this rusting process is a big harm to the whole industry. How can this process be avoided? Well, by introduction of a metal, zinc, that is electrochemically more negative than iron. This particular metal is then oxidized instead of the iron, and the steel substrate is kept in place. The particular metal, as mentioned, is zinc. Zinc is available in large volumes. It is fairly cheap and therefore perfectly suitable to be used as corrosion protective pigment. If instead of zinc we would use a metal that is in the electrochemical series more noble, for example copper, the adverse effect would occur. The copper would remain in place and iron would oxidize away. As we don't want this to occur, today we will talk about zinc as a corrosion protective pigment. Steel needs to be protected when used, for example, for small items like screws, fasteners, or brakes. These are typically used in automotive industry and are coated in a so-called dip spin process. Our topic for today is heavy-duty corrosion protection, protecting bridges, power poles, lamp posts, railway items, and so on and so forth with corrosion protective paints. You are all very familiar with heavy-duty corrosion protection. This is predominantly a solvent-borne epoxy, typically chemistry. It typically uses zinc-rich primers with minimum 85% zinc in the formulation. It is also a price-sensitive market, but nevertheless, we would want to penetrate with our ZincFLAKE products into this market. And our ZincFLAKE products are called ProFlake. ProFlake is an abbreviation standing for protective flakes. So instead of what you are used to in the standard zinc-rich primers as corrosion protective system, where zinc dust is used, which is a spherical species with a relatively low surface area, with a very small average particle size, meaning 3 microns average, and a small oil absorption value. Our offering is ProFlake, a flake-shaped zinc particle with a substantially higher oil absorption value, meaning a substantially higher specific surface and a higher binder uptake. This is very important to understand because it later on, as I will explain, influences the formulation of zinc flakes in corrosion protective systems. We produce our zinc flakes in a two-step production process, basically comprising out of step number 1, a melting process where zinc at round about 420 degrees is molten, and the liquid zinc mold is pressured through a nozzle into the air. This process is called atomization, and out of this atomization process, the result granular, more or less spherical particles. In the second step, we mill them, we grind them in a ball mill into the described flat zinc flake particles. This is done by using a lubricant, stearic acid, in order to avoid cold welding during the milling process. The milling predominantly is done in a dry milling process, but it can also be done in mineral spirit. Both options are possible to perform and are done in our factory. The current ProFlake zinc flake portfolio is relatively limited, sufficient to fulfill all the requirements. We have 2 zinc flake products in a powderous form of 2 different average particle sizes. A finer one, 14 micron, ProFlake 1400, and a coarser one, 20 microns, which is the standard pigment where we start initially to work with. If, however, you feel inconvenient working with powder, maybe because of safety concerns or dust creation, you can easily also use a zinc flake in paste form, whereby we offer a 90% pigment, 10% mineral spirit flake form, paste form of this ProFlake. Corrosion as such occurs in 3 different mechanisms. The first one is an inhibitive effect, which is typically provided by species like phosphates and chromides, and there is a large variety of different products available in that industry. This inhibitive effect is not used when using zinc, both zinc dust, but also zinc flakes. For the zinc flake and zinc dust pigments, there is a galvanic effect provided and also a barrier effect. These 2 effects contribute to the corrosion protective performance of zinc flakes. The barrier effect of especially zinc flakes can be easily detected from this picture. The zinc flakes align in the paint film, by that form a very long pathway for the moisture to penetrate to the steel substrate, and because of this barrier, moisture is repelled for a certain period of time from the steel substrate, so corrosion protection can occur. Also, a galvanic effect is of importance when using zinc flakes. With a direct zinc to iron contact, the through the flow of electrons, the zinc works as a sacrificial electrode, and instead of steel, the zinc pigments oxidize. And in the oxidization process, they form zinc oxide. And in addition to this, the zinc oxide generates an additional barrier protection. So you have galvanic process and a double barrier layer, the initial flake layer, and the barrier formation through the zinc oxide formation. Any pores and holes in the paint film are sealed by that zinc oxide. I mentioned already in the beginning that corrosion protection only occurs when a flow of electrons is possible. And the flow of electrons can occur, and zinc can work as a galvanic corrosion protective pigment when there is a flow of electron. A flow of electron can only occur when the particles get in touch with each other, and through the contact point, electrons or currency can flow. That point where the individual zinc particles get in touch with each other is called percolation threshold. And because zinc dust has a very low surface area, the loading of zinc dust into a formulation must be very high, meaning 85%, in order to generate the percolation threshold. With zinc flake, with the comparatively higher surface area, it is not necessary to load the formulation with that high amount of zinc flake particles. We recommend a PVC of 10 to 12% roundabout. Here you see more than 10%, meaning 35% weight loaded into the formulation. And this is absolutely sufficient to generate a percolation threshold in order to guarantee good corrosion protective with zinc flake. So you have, in comparison to zinc dust, and it is really important to understand and a change in mindset, lower loading of zinc into your formulation. Here, as a summary, the mechanisms of the corrosion protection. With zinc dust, you have an active corrosion protection through the galvanic properties. You have a certain passive corrosion protection because of the cementation process. Similar with the zinc flake, but in additional, because of the zinc flake layer formed, you have an additional initiative passive corrosion protection. We have called this two-in-one concept because by using zinc flake, you get initially an additional corrosion protective performance by the barrier layer formation. In the corrosion protection industry, there is a high degree of regulation through norms. I am convinced you are all familiar with the German DIN 12944 norm or the subsequent ISO and other norm regulation. And these norms so far did specify for certain buildings and in certain application a minimum zinc content of 85%, meaning it would have not been possible to use zinc flake with lower loading in the formulation to use in building industry according to a norm. This norm has now been changed into also a performance-based norm, meaning zinc is still specified in the norm, but not by 85% loading. It needs to be loaded into the formulation and provide a good performance, corrosion protective performance similar to that of zinc dust. The same applies for the American SSPC norm, Paint 20 norm. So far, again, specified minimum zinc dust content of 85%. Now Paint 29 is issued, which also allows to work with a lower zinc content as long as performance is the same as with zinc dust. In addition, we work at the moment with railway specification. This is the German railway specification number 100. Here still the zinc content in the formulation is specified, but we are working on getting a similar performance-based norm as well to allow us to use ZincFLAKE in railway specified coatings as well. There are in the German 12944 different corrosion categories, different classes, in total 5. And heavy-duty corrosion protection starts from C3 class onwards. The difference between the heavy-duty corrosion classes is the requirement and the atmosphere that is the corrosion protective coating is exposed to, and subsequently the film thickness that needs to be applied on the paint film. The heaviest class is C5 class, and in addition to that also a norm that in the past has been a separate norm for offshore applications has been included into this DIN 12944 norms as CX class. CX representing now in this norm context the offshore requirements. With our ZincFLAKES, we have proven we fulfill the C5 norm at least, and this can be achieved by a film build like this. And you see here a crosscut section through a typical corrosion protective system. You see the steel substrate. You see the epoxy primer with roundabout 12.5% PVC ZincFLAKE at the dry film thickness of 80 micron. On top of that, and that is no change to previous procedures, an intermediate containing mica-chaos iron oxide at a film thickness of 160 micron, and on top of that, finally, an 80 micron two-component polyurethane top coat. And with this system, we worked in order to fulfill successfully the C5 norm for heavy-duty corrosion protection. In this picture, I want to display you this film build, as just described, after 2,700 hours salt spray cycling test aging. And you see the scratch here at the bottom of the paint film, and you see a little bit of red rust occurring, but you don't see any rust creeping underneath the paint film. It is part of the testing also to include an adhesion testing procedure. This is done here at these 3 circles. And you see the numbers of the forces that is necessary to remove the paint from the paint film. But I want to show you in this slide a ZincFLAKE epoxy primer 2-component on sand-blasted steel SA2.5 at 65 microns after 1,700 hours salt spray test. And you see this paint film before salt spray test exposure, and you see the same panel after 1,700 hours salt spray testing And once again, there is a red rust formation here at the scratch, but no creeping underneath the paint film. And we have removed the paint film from this panel as just shown. And this is an enlargement of the cut here. So the evidence to display to you that this rusting is not occurring, is successfully prevented by using zinc flake pigments. You may now argue, okay, this is marketing material generated by Eckert in order to provide or to promote our zinc flake products. Therefore, we have approached in Germany, in the eastern German city of Dresden, a very well-reputed corrosion protective institute. And we have given them our paint and asked them to perform the corrosion protection test as per DIN 12944 for C5 class. And please believe me, it's only a German certificate that with this paint, with this formulation, using our zinc flake at 12.5% PVC, the C5 corrosion protective category is fulfilled. In addition, some years back, we started to coat a bridge in the southern German vicinity of Immenstadt nearby Munich with this 3-layer paint system as just described. And this is a railway bridge across a small river. And after 20 years of exposure, the railway bridge still exists and the corrosion protection still is active, is working. And you see this at a cross-cut test after 20 years. And you also see that there is some dirt and surface rust occurring on the bridge that can easily be removed from the surface. In addition, so we believe that we have fulfilled this C5 class and we can fulfill it. We are now, as a next step, working on proving the CX offshore norm, and I hope this will be available. The results I can display to you by the end of the year. As you all know, the difference for the CX, the offshore norm, is an exposure to UV radiation and subsequent water condensation, followed by a 3-day salt spray test and a 1-day exposure to low temperatures at -20 degrees, representing in total a typical offshore climate. This is repeated for several thousand cycles, and we have this testing started, and again, the results will hopefully be available by the end of the year. When you intend to use zinc flakes, it is very important to use them in an appropriate way to get the full benefits as just described. And I indicated already, you need to change your concept of using zinc dust in a dosage in the formulation. Our recommendation is a total PVC concentration of zinc flake and pigments and fillers of around about 35 to 45%. Out of this, PVC concentration for zinc flake being 12 to 20%. In the formulations as just described, we worked with 12.5% PVC zinc. The remaining PVC concentration is fillers and pigments. For your calculation, if you want to do this PVC calculation, the zinc flake have a solid 7.1 gram per cubic centimeter density. The incorporation of the zinc flakes into any binder chemistry is relatively simple. You can start with the binder and add at the required ratio the zinc flakes. You need some stirring. You preferably use a dissolver disc at a speed of 4 to 6 meters per second. That equals round about 2000 RPMs. And when you do this for 20 to 30 minutes, the zinc flakes should be incorporated accordingly. We target with this concept to all railway applications like trains, bridges, bridge repair systems, although it is not, the norm is not specified, but we are working with companies like this. Offshore constructions like oil platforms and pipelines, pipeline buildings, trucks, but also shop primers, including a very good weldability with these zinc flake formulations during the welding process, with the advantage that there is very, very small amounts of zinc fume generated. You may now ask, why should you change from the well-established zinc dust to zinc flake? Well, I would argue there is some ecological arguments to convert to zinc flakes. The first one is, with lower incorporation of zinc into your formulation, you reduce the heavy metal content. And this applies as well when the construction and buildings are cleaned and sandblasted. There is less zinc or heavy metal contamination in the soil. In shop primers, when these constructions are welded together, you have lower formation of zinc fumes. You can use with these zinc, you can formulate zinc flake primers to a very low VOC system. We have started also to introduce aqueous systems with zinc flake formulations. By use of zinc flake at a lower dosage in the formulation, you reduce the weight of your coating. And imagine an oil platform with tons and tons of coating on the platform that can sum up to several single-digit tons savings of paint. And this increases the stability of the oil platform construction. This allows to build other items onto the oil platform. But also you gain formulation flexibility. With only 35% by weight, meaning around about 12% PVC, zinc flake in the formulation, you have about 65% of other components that you can introduce in the formulation, like binder, like additive, like whatever solvent you want. And with a higher binder content, you increase your intercoat adhesion and the substrate adhesion of the zinc flake system. Using zinc dust primers, you have to use 85% zinc dust particles in the formulation, allowing you only 15% of other components in the formulation. So you gain flexibility. You get, as mentioned, adhesion and cohesion includes proper improvement, and the film flexibility is also better because of the higher binder content. I indicated that we start with an offering of 3 different products, 2 powder products and 1 paste product. And we will introduce shortly a ProFlake 3000 zinc flake powder, which is designed to meet especially the commercial requirements of this corrosion protective market, meaning it will be a product that we can offer at a good price with a good corrosion protective performance. Talking about commercial aspects, we still have to face the pricing of zinc dust. Zinc dust price is around about 3.5 euros per kilogram, depending on the current situation of LME. Zinc flake is round about 3 times higher in price if compared to zinc dust. However, please consider that only you need 1/3 of the zinc flake in comparison to zinc dust. So the higher purchase price of zinc flake is by that already compensated by a lower loading. And with the currently rocket high prices of raw materials, including metals, the lower metal zinc you can use in your formulation, you gain even better price advantage. In addition to that, we believe that round about 30% higher paint yield can be achieved with a zinc flake based formulation in comparison to a zinc dust primer. So in the end, I am convinced it is possible to achieve around about 15 to 20% savings by using zinc flake, even though the initial buying price of zinc flake is higher if compared to zinc dust. Saying that, I am at the end of this presentation. I thank you for your attention. I hope it was of interest and generated enough interest for you to start working with zinc flake, offering you all these advantages. And for now, I would leave the presentation mode and would turn back to Alexandre. Alexandre, it's your turn now.
Ok, Peter, mais uma vez, muito obrigado pela excelente apresentação nesse tema sempre sempre esse tema tão interessante que é a corrosão, né? Lembrando a todos agora que a gente está abrindo a sessão de perguntas e respostas, e vocês podem ver na barra inferior aqui, vocês têm o Q&A e fazer as perguntas pelo chat também, tá? Ou quem se sentir confortável pode levantar a mãozinha, nosso pessoal, o Fernando, vai liberar o acesso e vocês podem fazer a pergunta diretamente ao Peter, se vocês acharem necessário, tá? Ou se não, só escreve no chat aqui que a gente já passa para ele. Peter, a gente tem algumas perguntas aqui, já gostaria de começar. Zinc flake pode ser utilizado com todos os tipos de resina? Algum inconveniente com base d'água?
From our side, the resin combined with zinc flake is of no relevance. It is a universal product. When using zinc flake in a powderous form, you do not introduce any solvents into the formulation. So the formulation flexibility is very high. So typically we work with epoxy systems, acrylic systems, polyesters, of course, with a higher variety of epoxies, but overall it is possible to use any resin system. Waterborne is a little bit a topic, I would say, more in Europe, where there is high concern about ecological topics. So we have generated specially pre-treated zinc flakes that give an initial protection against reaction of zinc with water and still keep the corrosion protective performance of the standard zinc flakes. So I would say universal use of zinc flake is possible, and also even we have customers using zinc flake in a powderless form in powder coatings. So similar principles as mentioned apply. So yes, Any resin system is possible. Any application technology is possible if adjusted a little bit in the formulation.
Muito obrigado, Peter. Mais uma pergunta já dentro dessa linha é se há alguma limitação de utilização do ZincFLAKE também com pigmentos orgânicos e inorgânicos.
We would indeed, I would indeed answer that question to what I have presented with the PVC content. So an overdosage is of pigments in general is not recommendable. Then you reduce the film characteristics. But from the pigment side, of course, you can use any fillers like talc, barium sulfate, iron oxides. So these do not harm the corrosion protection properties, if provided the PVC recommendations as given are followed. Yeah, but pigment wise, use whatever is required. Yeah?
Obrigado, Peter. Mais uma aqui. Existe alguma recomendação em especial para formulações à base de ZincFLAKE? Algum tipo de homogeneização especial ou algo assim? E outra, já linkada a essa pergunta também, se a Eckert pode disponibilizar algumas formulações iniciais para a formulação, né?
Yes, we have some guideline formulations where you can get the formulation concept from. Depending on the requirement, we have epoxies, we have acrylics, so whatever you require, we can give you a starting point. These formulations you can translate into your local available raw materials. So yes, if that is a requirement, you can get an idea about pigment loadings, viscosity, zinc loading, also in comparison to other filler materials and pigments. And if that is not sufficient, we have a good laboratory in Germany, but also Colomix. Maybe we can give you some initial help through that as well. Yes.
Obrigado, Peter. Mais uma pergunta. Pode-se usar ZincFLAKE em wash primers? E como é a adesão dessa tinta, né, do wash primer, sobre metais?
I would say that the characteristics of a wash primer depend very much on the resin system that is used. So the corrosion protection is coming from ZincFLAKE, but adhesion properties, UV stability is mainly coming from the resin system that is used. So the answer is yes. ZincFLAKE can be used in wash primers, and even as an advantage, because of the lamellar structure of ZincFLAKEs, these thin layer applied wash primers recommend to use ZincFLAKEs. So the answer definitely is yes.
Excelente. Muito obrigado, Peter. Mais uma. Isso é uma pergunta do Glauber Monte. Em relação aos fosfatos de zinco convencionais ou modificados, o ZincFLAKE é mais efetivo? E sobre a estabilidade do branco, é mantido ou tem a tendência de amarelar como produtos utilizados à base de nitrito de sódio?
First of all, the zinc flakes can be combined with zinc phosphates. That is not a problem. Of course, the zinc flakes will bring in a certain metallic appearance, a grayish metallic appearance, which remains. The yellowing typically occurs, which, however, is related to the binder system that is used. So the typical combination of zinc flake and zinc phosphates with epoxy resins display a yellowing effect, which is, however, coming from the epoxy system. There are various epoxy systems available that are less yellowing, but in the end, it is a matter of the resin system that is used.
Obrigado, Peter. Mais uma pergunta do Michael Goulart. Há necessidade de se usar algum agente para melhorar a orientação das partículas do zinc flake no filme?
No, typically we recommend orientation leveling agents when aluminum flakes are being used in order to improve on the flake orientation, the flake alignment in the paint film. For zinc flake, that is not necessary. The reason is that the amount of zinc flakes is substantially higher in a formulation, as mentioned, 35%. And the second reason is we do not recommend to use these. They have negative impact on the corrosion protective performance of the paint system. So no, we would not recommend to use orientation leveling agents.
Obrigado, Peter. Mais uma pergunta aqui. A Color Mix do Marcos Pacheco. A Color Mix já tem amostras desse zinc flake para fornecer para testes? Sim, a gente tem as amostras disponíveis. Então, se vocês se interessarem, vocês podem fazer contato com a nossa equipe técnica comercial ou através do nosso website. Tem um chat lá. Você tem também os telefones das vendedoras internas. Então, a Color Mix já tem amostras disponíveis para providenciar para todos que se interessarem, tá? Mais uma pergunta, Peter, novamente do Michael Goulart. Ele pode ser usado em tintas para aplicação em alta temperatura, um exemplo acima de 200 graus Celsius?
Yes, definitely it can. As mentioned, zinc flake has a melting temperature of around about 420 degrees. That is where we melt the zinc in the production process. So definitely 200 degrees C is no problem.
Obrigado, Peter. Mais uma pergunta do Marcos Roberto Segala. Existem parâmetros específicos de extrusão para usar ProFlake em tintas em pó?
Typically, we have worked with zinc flakes in dry blend process in powder coating applications. I have to admit, I would want to take up this question for my powder coatings colleagues, whether they have experience. I could imagine that is overall possible, but we will come back to you on this. At this moment in time, we have worked with dry blend processes for powder coatings only, according to my knowledge. But we will come back to you on that question, and we will give you advice.
Obrigado, Peter. Aqui algumas coisas mais do chat. O Éder de la Justina está mandando os parabéns para você pela excelente apresentação. Muito obrigado, Éder, pela presença.
Thank you very much. Yeah.
Eles já estão testando no nosso produto lá. O Gustavo Azevedo, no sistema base d'água tem alguma recomendação para diminuir a formação de gás hidrogênio?
Yeah, that is a problem with zinc in aqueous formulations. So as you know, zinc reacts with water, forming hydrogen gas. If you want to work with zinc flakes as such, the first initial recommendation is use a neutral pH system. So we very often find that waterborne systems have a pH value that is very acidic, pH 4, 5. If you neutralize this to pH 7 and 8, you already can benefit from a better a lower hydrogen gas formation. But in the end, I would also recommend to use a pre-stabilized zinc flake. So there we have some product offerings available which are already pre-stabilized and suppress the hydrogen gas formation even better. But the initial step would be start with a more or less neutral pH 7 paint system and see where you get there. But probably I would expect that is not sufficient. Yeah, so you need these pre-stabilized zinc flakes.
Excelente, Peter. Muitas perguntas aqui, hein? E muitas pessoas também agradecendo pela excelente apresentação. Mas temos uma pergunta aqui do Marcos Pacheco. É certo que as cargas inertes colocadas junto com o zinc flake não atrapalharão a transferência de elétrons se for mantido o PVC indicado?
Yes, we would say that as long as you have around about 12.5% PVC, which means 35% by weight in the formulation, the electron transfer should occur, and that is yeah. If you get lower, some companies they can get away maybe with 11%, something like that. But initially, I would even recommend initially to start with 15% PVC and then reduce gradually. So maybe you can end up in your individual formulation with 12, 11%, maybe 10% even. But lower than that is difficult. Yeah.
Obrigado, Peter. Mais uma pergunta aqui do Glauber Monte. O zinc flakes substituiria um convertedor de ferrugem ou poderá ser aplicado diretamente sobre a oxidação?
No, a rust conversion does not occur. Actually, in several cases, we have seen that, for example, waterborne zinc systems, you need a flash rust inhibitor to add, or if there is a steel substrate that is not well prepared, the corrosion protection performance is not so good. So the answer is no. Unfortunately, the zinc does not act as a rust converter. The reason is that by nature, the zinc metal is not providing inhibitive corrosion protection mechanism. So a rust conversion is not possible. You have to take measures to avoid this before application of the zinc-rich primer, or zinc flake primer, and also zinc dust primer. That is the same.
Obrigado, Peter. Aqui um comentário do Henrik, que seria interessante comentar sobre o risco do zinc flake contra as formas em pó, que os alumínios em pó geralmente são explosivos e, no caso do zinc flake, ele não seria.
Yeah.
Se você pode comentar um pouquinho a respeito disso.
In general, our understanding is that zinc dust as such can be used in very good ways in any formulations, with the advantage you have 100% pigment, no other component introduced into your formulation. In a laboratory scale that works, the incorporation of zinc dust into any paint system is fairly good and easy if the advice is followed. However, we have some companies saying that zinc, although it is a relatively heavy product, in a production scale generates dust when the drum is emptied into the reactor vessel. And in that case, we recommend this zinc paste, 10% mineral spirit in the paste form. And this is basically, you can call it also a dedusted powder. This completely avoids any dust formation. So in several companies, there is very high regulations with working safety in production. And this includes avoiding any dust formation during the mixing and processing steps. So in that case, we would recommend zinc flake paste, ProFlake paste, but it is a safety aspect.
Obrigado, Peter. Mais uma pergunta do Carlos Sanches, tá? Eles usam atualmente ZincFLAKE AT. Ele gostaria de saber quais são as diferenças com os outros tipos que foi mencionado aqui, como 1590, 1400 e o 2000.
Can you repeat the product, or what is?
Qual seria a diferença, né, sobre os outros 3 tipos de produtos mencionados, como o 1590, 1400 e o 2000?
Okay, I think I understand. Okay. So as a starting point, and all the formulations and pictures that I displayed during the presentation were made with Zinc ProFlake 2000, which is a 20 micron type product. This is, as a starting point, a very good recommendation. Some companies want to use a very fine zinc flake product, and then they use the ProFlake 1400 in order to generate smoother surface, maybe also lowering the zinc content in the formulation. So the corrosion protective properties will be the same, disregard of what product you use. The use may influence your film properties like pigment loading, like leveling, surface leveling, paint flexibility, and so on and so forth. So I would say basically whatever product you want to use from a corrosion protective performance point of view, it is disregard which product you prefer. Yeah. But as mentioned, in all the examples which I have displayed were made by using ProFlake 2000.
Peter, sorry, it's Christine. The customer wants to know what is the relation with ZincFLAKE AT that they are using regarding this ProFlake.
80, okay,
80,
yeah.
Yes.
Okay, thank you, Chris. So by nature, ZincFLAKE AT, of course, is a zinc flake product, and it can be used in the application. ZincFLAKE AT is designed to be used in these dip spin processes where very, very thin film layers are applied. And it is a product that does not contain any big particles, oversized particles. So in the end, in a heavy-duty corrosion application, it is not necessary to remove all coarse particles from the zinc AT. So therefore, we have generated these ProFlake type products to be used in corrosion protective systems. So in the end, ProFlake is a more commercial offering in comparison to ZincFLAKE AT.
Ok, obrigado, Peter. Tem uma pergunta aqui, qual seria o produto mais indicado contra um zinco pré-estabilizado? Essa pergunta é do Gustavo Acevedo.
These products we sell at the moment under a VP number. VP in our system is experimental product. These products would be commercially available, but they do not have such a long sales history, and we are still modifying these products. So these VP products are available upon request for testing, and in principle, it is a stabilization with some organic chemistry on the surface to prevent this zinc-water reaction from occurring. So it is a special VP, we call it VP, followed by a 5-digit number, VP product.
Mm-hmm.
I will send the numbers to you, Alessandra and Chris, so you can, yes. But these products is available. We have developed them, as mentioned, for the European market, especially where there is a very high concern about ecological considerations, sustainability and this type of thing. And yeah, but there are 2 products available. I'll give you the number. I'll let you know the numbers later on.
Ok. Lembrando para todo mundo que a apresentação vai ficar gravada no YouTube, tá? E nós vamos ter a apresentação também ela traduzida. Então, quem perdeu algum detalhe ou quiser verificar essa apresentação com mais calma depois, é só entrar no nosso canal do YouTube, que a apresentação vai estar disponível lá. Há uma pergunta aqui a respeito de quais grades vai ser disponibilizado isso no Brasil ou na América do Sul, que a gente tem algumas pessoas da América do Sul. Eu não sei, Cristine, se você gostaria de responder essa pergunta.
Sim, sim. Todos esses grades que ele mencionou, tanto o ZincFLAKE quanto o ProFlake, nós podemos disponibilizar como amostra. A Color Mix já tem os principais, eu acho que o ProFlake 2000, aqui em estoque de amostra, mas se for algum outro que ele tenha mencionado, a gente pode trazer rapidamente para cá também.
Ok. Peter, terminamos as perguntas, né? Da parte da Color Mix, queria agradecer muito a sua apresentação, muito clara, com muitos detalhes, sempre desse tema que é super importante, que é a corrosão. Então, se você desejar fazer os seus esclarecimentos finais, sua despedida, eu já fecho aqui depois.
Yes, first of all, I thank the whole audience and the active participation in the presentation. Thank you very much. I would be delighted to see one or the other person, as mentioned in the beginning, face to face. I thank Colormix for the excellent presentation. Abreu, Alexandre, Chris, thank you very much for all this. Fernando, for the IT support, and Maria, thank you very much for the translation. For me, the good thing is now German time is 5 o'clock. I can go home. For me, it's finish of the day. Greetings to Brazil. You have a little bit longer to work, but yes.
Peter, só mais uma coisa. Acho que a gente tem alguém com a mão levantada aqui. Então, o Éder, você gostaria de falar,
okay,
fazer alguma pergunta ou falar diretamente? Fernando, se você puder ajudá-lo aí para que ele possa participar.
Ele pode falar.
Pronto, Éder.
Tem que só tirar sair do mute, ele pode falar.
Uhum. Éder, tudo bem? Pode ser que seja algum errinho aí, mas, Éder, qualquer pergunta, qualquer dúvida, a gente vai encaminhar depois para o Peter e para a Cristine, tá? Do nosso lado, Color Mix, queria agradecer muito a Eckhart, a Cristine, ao Peter por essa maravilhosa apresentação, agradecer a todos que participaram pelas perguntas, foi muito enriquecedor. E a gente agradece muito a presença de todos. Abreu, algum comentário? Tá tudo certo. Então,
congratulations, Peter. Congratulations.
Okay.
Obrigado.
Muito obrigado a todos. Tenham um bom dia. Tá? Muito obrigado. Um abraço. Peter, muito obrigado. Mais uma vez.
Obrigada a todos.
All the best to Brazil and greetings. Take good care of yourself. Bye-bye.
Ok, bye-bye.